Hi, greetings students and welcome back. Thank you once again for watching the TVET COVID-19 Learner Support Program. My name is Vasan Naika and I'm from the UTVET College in Pietermaritzburg. Today we're going to continue with the introduction to PLCs, and hopefully by the end of this lecture I'm going to teach you how to actually write a complete program for the traffic light sequence, which is basically using timers. In order to do that, I'm just going to recap where we stepped off last time. Remember, we had just introduced the circuit to you, and I said I'm going to leave it exactly as it is. We then programmed it into the PLC, and we realized that the timer did not switch off the red light after the given time of 5 seconds. So just to go back to the circuit that you have in front of you, remember I asked you to actually kind of work out why it didn't. Let me just put that circuit up again. All right, and as you can see, yes, I have to program the timer, but at no stage in my program did I ask it to switch off Q6.2. So remember, the program only does what you tell it to do. So in order for me to do that, what I'm going to have to do is, let me just move this a little bit. Okay, that was Q6.2, which is our red light. Okay, at this point, I'm going to put in a normally closed switch. All right, what will be the address of the switch? Remember, we said the timer can have as many normally open or normally closed switches attached to it. So I'm going to call this T1. So how is that going to work? Well, basically, after the 5-second time, T1 would actually energize, and once T1 is energized, that normally closed switch would become normally open, and the red light should actually switch off. So let's go and program that into my existing program. Okay, just going to stop it for now. Okay, this was the existing program that we had previously, where we've got the red light to actually start the timer. At this point now, I said I'm going to put in a normally closed switch, and I'm going to call that T1. All right, and if I now download this particular program to the PLC, download. Okay, you can see the stop light is energized. Sorry, the stop button is energized. T1 is energized. That means it's normally closed. There's current up to my start button, and there's current up to my normally open contactor of Q6.2. If I now press the start button, okay, you can see that my red light is on, and after 5 seconds it automatically switches off. I think the one good thing about it as well is just to see it more clearly. What I'm going to do is I'm going to change the time to 10 seconds. Now that's the beauty of using the internal timers. I don't have to physically go and interfere with any wiring or any hard wired timers. All I have to do is change the time on my program. I download this. Okay, and the other thing I want you to watch is that this timer actually times down from 10 seconds, all right? And when it does, it opens this normally closed contact here, and my light will switch off. So let's switch it on again and leave it. Okay, you can see the timer timing down. Okay, 10 seconds gone, and it switched the red light off. So that's a basic circuit using a timer, and in this case, it is a 10-second timer, and it's an on-delay timer. Now, the fourth circuit that we said we were going to discuss is your interlocking circuit. Interlocking circuits are used especially where you want to keep something off as a security measure. That means I can't turn it on unless something else is turned off. And we discussed that you can have two motors and only one can run at a time, and if one is on, the other is going to go off. However, for this particular circuit, I'm going to use the simulator, all right, because I don't have two motors to actually demonstrate this for you. So what I'm going to do is quickly set up the simulator here, the PLC simulator. I'm going to use two motors in the simulator with two start and stop buttons, all right, and I'm then going to program that and see how it runs on the simulator itself. So let's do that now. Okay, I'm going to save this program because I'm going to come back to it later. File, save. Remember, it's called my latching circuit. I'm going to close that. Okay, and the program we're actually going to use now is Process Simulator. We're going to use it again later on when we have some time. But for now, I'm just going to use it to demonstrate the latching circuit. Okay, it's File, New. I'm going to create a new circuit. And what I'm going to do is I'm going to insert two motors. That's motor 1. And that's motor 2. Okay? Attached to these two motors, I'm actually going to put in two conveyor belts. So conveyor belt, one for motor 1. Okay, just increase the size there. And one for motor 2. Okay, so when this motor runs, conveyor belt 1 will run, and when this motor runs, conveyor belt 2 will run. I'm just going to put an object on it so that you can actually see it running. Let's put anything. What can we put? Okay, let's use a box. Okay, so when motor 1 runs, the top conveyor would run. When motor 2 runs, the top conveyor will run. And I'm obviously now going to introduce a start button for motor 1 and a stop button. And a start button for motor 2 and a stop button. Okay, I can add symbolic names later on, but for now I'm just going to leave it at that. because I'm just going to demonstrate the interlocking circuit. Obviously, imagine this is you now in the field. You've connected up the motors. You've connected up the start buttons for each of them. Those are your contactor coils. I now want to connect this up to the PLC. I'll obviously have to connect the 2 start buttons to your input and the 2 coils, Q1 and Q2, to your output. So I'll have to give it addresses. And I will do that here onto Plc Addressing. Okay, all I'm going to say is the start button for motor 1, I'm going to call that I0.0, and the stop button for motor 1, I0.1. The start button for motor 2, I0.2, and the stop button for motor 2, I0.3. And then on my output side, Q0.0 would be contactor 1, and Q0.0 would be contactor 2. I've now assigned addresses to all of my field devices. I can now continue with the programming. So let's look at the program itself. Okay, I'm going to open up next ladder. We've done this before, so that's why I'm going through it quite fast. Project name Interlock. Finish. Okay, and I'm going to insert a 7 function, and I'm going to call this the interlock circuit. Okay, remember I said we also have to tell my operating block which one to use. So I'm only going to use FC1, which is my interlocking circuit. And you can see here, OB1 will only be using my interlocking circuit. Let's change, yes, save changes. I'm going to close this. Okay, FC1 is view details. Okay, FC1 is now black, and I have to program my interlocking circuit in it. Now, if I look at the circuit here, I'm just going to put it back onto the board so you can understand it or see it and understand it. All right, I said we are going to do or program a basic interlocking circuit, and because I don't have 2 motors here, I'm actually going to use the simulator. But remember, your addresses are X's and Y's for inputs and outputs, but I'm going to use Q's and zeros. So if I look at the first line of programming, okay, for motor 1, it's going to have its start, it's going to have its stop button, it's going to have its output coil, and it's going to have a latching circuit. All right? Okay, we said that when we use the simulator, we had to assign addresses to our field devices. Okay? And for the start button for motor 1, we assigned it I0.0. And for the stop button, we assigned the address I0.1. So that was your start, and that was your stop. Okay? Your output contactor for motor 1 is Q0.0. So this is motor 1. And remember, in order for motor 1 to stay on, I need to latch it. And this normally open contact now would be an auxiliary contact attached to your output coil Q0.0, so it will have the same address, Q0.0. Okay, for motor 2, the same story. We gave it its own start button, we gave it its own stop button, output coil, and a latch. Okay, we called the input address for motor 2 to start. Sorry. I0.3, I0.4, okay, and we call this Q0.0. And we call this normally open, sorry, Q0.1. And we call this Q0.1, which is the latch. Okay, for this particular circuit. Okay, so what I'm going to do now, before I actually show you how the interlock system actually works, I'm going to program this into the PLC, all right, and get both those motors to run. So let's do that. To make it easier for me, I'm actually going to go to my options. First of all, I'm going to include my symbol table, and I'm going to say M1 or M1 referring to motor 1. I'm going to call that start, and if I put in the address there, I0.0. Okay, the next thing is M1 stop. Okay, your address I0.1, M2 start, I0.3, actually 0.2 and 0.3. I think we call them, correction there, I think we call these 0.2 and 0.3 because we use the first 4 inputs. 00, 01, 02, 03. Okay, I can just double check that on the simulator itself that we've got the correct addresses. So if I go back to the process simulator and just check on the parameters, PLC addressing, inputs, yes, it's I0.0, 0.1, 0.2, and 0.3. That is correct. All right, let's go back to our circuit. I'm still under my symbol editor. So M2 stop would be I0.3. Then with regards to my motors itself, MOTOR, motor 1 would be Q0.0, enter, and motor 2 would be Q0.1, enter. Okay, so those are basically the 6 inputs and outputs that I have. Remember, Q0.0 and 0.1 are auxiliary switches, so I don't need to put them in my symbol table. The beauty of this is when you are now programming, okay, these symbolic names will come up automatically with your addresses, and it will assist you with the actual programming sequence. So save. I'm going to now close that. Okay, so let's do the first line of programming. Normally open switch. Okay, normally close switch, a coil, and then I'm going to put a latch, another normally open switch, and insert a new network, same thing, normally open, normally close, output coil, and then my latch. Okay, so I have the 2 circuits. I just need to put in my addresses. If I type in here now I0.0, you can see automatically the symbol name under it comes up as M1 start or motor 1 start. If I put in here I0.1, it says M1 stop, so it means I'm actually going in the right direction. I now put in Q0.0, it says motor 1, and I now have to call the latching circuit, or normally open Q0.0. It also refers to this as motor 1, meaning that this auxiliary switch belongs to that output coil. I'll do the same for the second circuit, I0.2, actually I0.3, 0.2, M1 start, I0.3, M1 stop, Q0.1, motor 2, and this again, the auxiliary switch will be Q0.1, motor 2. I now have both my circuits. I want to save this. Okay, now remember, at this time I'm not downloading to the PLC, I'm actually downloading to the simulator. So what I'm actually first going to do is minimize this, close that, no, yes, no. Okay, I'm going to link the simulator to the PLC program. It's asking me, do you want to connect the simulator? I'm going to say OK. I'm then going to go back to my Somatic Manager, link this now. I'm going to say OK. Okay, I'm going to use an MPI cable, which is basically a virtual cable. Okay, PLC is in stop mode. I can now download OB1 and FC1. So go to OB1, download it to the simulator. Oh, before we do that, if I go back to my simulator itself and I put it in run mode, if I press the start button here, you see nothing happens. If I press this start button, nothing happens, simply because I haven't yet downloaded the program. So let's go back. FC1, I'm now going to download it. Yes. Okay, I'm now going to put it in run mode. Okay, and if I go back and look at my process simulator now, if I press start, okay, let's see what we didn't do. Oh, okay. I need to get instructions from the PLC itself, so I'm going to say yes, yes. Now if I press the start, you can see motor 1 runs, stop, it runs. Start, stop. Let's try motor 2, start, stop, start, stop. So the purpose of the interlocking circuit was for me to demonstrate that if motor 1 is running, you cannot start motor 2. So if you look at this scenario, motor 1 is running, I can start motor 2. Problem. Okay? So let's go back and revisit the program. And unlike hardwiring PLC, where hardwiring circuits where you have to physically now go and put interlocking wiring through both your contactor coils, all you have to do here is put in a simple bit of logic on both your diagrams, and you would see that it works. So all I have to do is tell the PLC when Q0.0 is running, this cannot be turned on. All right? So all I'll do is at this point put in an interlock switch that says normally closed. And I will call this Q0.0. So what would happen? When I press the start button, Q0.0 is energized, and for as long as it's energized, this would be an open switch, and this can never be turned on. All right? And I will do the same thing for Q0.1. If I energize Q0.1, that normally closed contactor will break, and I will never be able to energize Q0.0. If I start motor 1 and try and start motor 2, not going to happen. If I stop motor 1, now I start motor 2, it will work. And I try to start motor 1 again, it will not work. So basically, the auxiliary contact from Q2 keeps that permanently off, and the auxiliary contact from Q1 will keep that permanently off. If I stop motor 1 now, all right, you'll see I'll be able to start motor 2. And that is how a basic interlocking circuit works. And it's used in various purposes in industry. One of the most important ones is your start delta run. Remember, your main contactor comes in, and when you're starting with star, the star contactor is in, and it interlocks. That means you cannot start delta until a predetermined time. The star switches off, and then you can start delta. All right, and that basically, I hope, gives you an understanding of how interlocking works, and it can be used for various other purposes in your programming, depending on the type of question they ask you for an examination. For example, you've got 3 motors, and only 2 can run at a particular time. The third one must not be able to start unless one of the others switches off. Same thing, interlocking switches. Okay, now that we've actually got the interlocking working, I just want to add one more thing, which is an emergency stop, which is actually quite a handy tool in industry in the case, basically, of an emergency or you need to stop something very quickly. All right, I'm just going to add the emergency stop here. And okay, it is a normally closed switch. I'm going to now give it an address, and on my PLC, I'm going to call it I0.4. Okay, I'm going to save that, close it. If I now go back to my ladder network, all I have to do is add in I0.4 as a normally closed contact here. All right, 0.4, enter. All right, 0.4. And insert another one here. And I can also include that emergency stop in my symbol table. And if I save that and go back to my circuit, I can see now it says emergency stop. Basically what this does now, if your emergency stop button is hit, neither motor 1 nor motor 2 will be able to start. All right, I need to download this new program to the PLC, so I'm going to put it in stop mode, download. I now put it in run. Okay, if I go to my process sim, put it in start motor 1. Okay. Start motor 1, it can start, remember, while motor 1 is starting, all right, I cannot start motor 2. You can see there, that's still the interlock. Unless I stop motor 1, I can start motor 2, and then press stop. If I now hit my emergency stop button, which is that one, okay, you'll find I won't be able to start motor 1, nor will I be able to start motor 2. So basically, on the circuit itself, all right, all I had to do was put in 2 normally closed switches here and call that your emergency stop, and another one here, and that's your emergency stop. So once those circuits are broken, you'll find you'll never be able to start either of these motors. Sometimes in industry it's a key switch. The supervisor has to come in, turn on the key switch, and then you can actually continue. That's obviously after you found the fault or found the reason for the emergency stop. I'm going to leave you with that for now. What I'd like you to do is practice these circuits that we've done. We've done 4, which is your basic latching circuit, your start-stop, your timer, and your interlocking circuits. What I'm going to do at the next session is continue from here and program the complete robot sequence, and also try and do another program on the simulator for you. For now, as I always say, keep safe, look after yourself, look after your loved ones, and sanitize. Thank you.